Hey, good morning, Algebra 1. How are you today? Yeah, look at that. Yeah, you're all still not here. All right, well, hey, it's Monday. It's the 27th of April, and we get to graph another parabola. What could be more fun than that on a bright and sunshiny Monday morning? And yeah, it is kind of bright and sunny outside. It's kind of nice. All right, so this is what I'm going to do. Get prepped up here to graph these parabolas for Chapter 9. We're going to learn how to solve them by graphing. But again, if you can't graph it, you're going to have a tough time. So right now, we're going to go into the solve mode. We're going to look at here graphing the parabola. Remember, I need 5 points to graph a parabola. A lot of you are turning homework in with 3 points, and a lot of you are still drawing me parabolas that look like absolute value functions. Stop that. They're not pointy. Parabola has a beautiful curve at the bottom, okay? It's a curve, all right? So let's have a look at something that's a little bit complicated. I picked one here today that's got a lot of components you're not going to like, those little things called fractions out there, because I know they really freak you out. So here you go. All right, so this is what we're going to start with. The directions are going to say graph this. And remember, I need 5 points. So you start off with f of x is equal to 2x squared minus 3x minus 5. So let's start by identifying the a, the b, and the c. Okay? Now later when we introduce ourselves to the quadratic formula, you're going to know how to do this. Now remember, a. The number in front of the squared term is a. That coefficient is a. Oh, standard form. I almost forgot to mention. This got to be in standard form. Put it in standard form first. All right? So now the a is 2. The coefficient in front of the single x, the x to the 1 power, that's a negative 3. And the number hanging on the end, that constant on the end, that should be a negative 5. That should be a negative 5. Let me fix that. Make that a negative 5. Put a little minus sign in there. There we go. Now it's a negative 5, okay? All right, negative 5. On the end is a negative 5. I hope we got that. Okay, so to find the axis symmetry, x is equal to negative b over 2a. You need that formula. A lot of you guys are writing me say, hey, I don't understand how to start this. Well, that's how you start it. And you have to know that. So you've got to be able to identify your a, b, and c. And remember, don't forget that minus sign. If there's a minus sign there, you kind of need it, okay? That's going to be your y-axis intercept, by the way. All right, so negative b over 2a. In our case, b is a negative 3, so the opposite of a negative 3 is a positive 3, and 2 times 2 is 4. So the axis of symmetry is x is equal to 3/4. Isn't that beautiful? Now, the step 2, thou shalt find the vertex. Okay, the vertex. Remember, the vertex is on the axis of symmetry, so that x value from your axis of symmetry, that is the x value of the vertex. So how do you find the y value? That big fat space right there, that's the y value. We kind of need it. Well, remember, f of x, y, interchangeable. So take your 3/4 and plug it in for x. So y is equal to 2 times 3/4 squared minus 3 times 3/4 minus 5. Love them fractions, people. Love them fractions. All right, remember, 3/4 squared, we got to square the top, square the bottom. 9/16 times 2 minus 9/4 minus 5. Clean that up a little bit. Now, I did a little reducing there in that first term, so I got 9/8 minus 9/4. Now, you're going to notice a relationship between that first term and the second term. You should be able to see something about that later you're going to use that as a check to make sure you're doing these right. All right, minus 5, and you clean all that up, you get negative 49/8. So the vertex, the y component of the vertex is negative 49/8. So there's my vertex. Now I changed it because when you graph it, you're going to know it's like negative 6 1/8. Okay, not bad. Now I need some x-axis intercepts. I need a y-axis intercept. Da 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 da. Okay. All right. So let's come over here. Now, we're going to factor this thing. Remember, every point on the x-axis has a y value of 0. So, I'm going to take what I started with, f of x is equal to 2x squared minus 3x minus 5, and I'm going to set it equal to 0. Okay? Now, this is kind of a bummer. It will factor, and we always check for that. And what do we always do first before we factor? We look for a greatest common factor. Ain't got one. All right. So we have to use the AC method. Factors of negative 10 that add to a 3. Now, how did I get the negative 10? I multiplied the 2 times the negative 5, hence the AC method. You multiply A times C, and you take that product, and then you factor it. Now you find factors of that product that will add to the negative 3. So if you take negative 5 times 2, negative 5 times 2, that happens to be negative 10, and look at that. If you factor the factors, because negative 5 plus 2 is negative 3, boom. Now take those factors. Those 4 numbers are going to fit in these 4 slots. Now I've already loaded them up there for you. Notice that I took factors these. If they split, in other words, that one to the front and that one went to the end, they split, those two, that's a negative 5 and a 1, negative 5 and a 1. Now remember, one of these will be negative, not sure which one yet. They will group, okay? Split, they grouped, okay? So those are my 2 factors. Now please, you can FOIL this out and check it to make sure you're right. We're right. Now, take each individual factor, set it equal to 0, and solve. So x is equal to 5 halves, and x is equal to negative 1. So what do my x-axis intercepts look like? They look like that, okay? Now, let's graph it. Okay, so here it is. So I let GeoGebra throw this up there for us. What you'd have done, you'd have had an x and y axis on a grid. You would have drew the axis of symmetry, that vertical line there that goes through 3/4. On that vertical line, x is equal to 3/4, you'd have went down there and you'd have put your vertex, okay? There it is, 3/4 negative 49/8, or negative 6 1/4. Now, GeoGebra rounded that up to 6.13. It should be 6.125, okay? So you did that. Now your x-axis intercepts. You found that one, 2.5, 0, or 5 halves, 0, and negative 1, 0. Now I've been harping on you. How many points do you need to make a parabola? You need 5. Now look at this. Look at your axis of symmetry, okay? Pick a nice number. Go to 2. If you plug a 2 in for x, you will find that y is negative 3. Okay? Use your rules of symmetry, okay? You can put another dot over here, okay? Now, if you don't want to work with the fractions, don't. Go up to 3. Pick another point, okay? But you can get your 5 points. Look at your graph. Plug them in, okay? You can do this. It's not that hard. All right. In fact, for this point right here, I went 1 1/4 over. I'm going to go 1 1/4 this way. So what's 3/4 minus 1 1/4? Oh, my computer just shut off. Let's bring you back. Well, anyway, we really don't need it back. But that's how you graph this parabola, okay? That's how you do it. So 3 steps, okay? There's beautiful King Air. All right, so the first thing you do, find your axis of symmetry. Find your axis of symmetry. How do you do that? Boom, like that. Identify your A, B, and C. And don't forget your minus sign like I did, okay? Then you need to find your vertex. The vertex is on the axis of symmetry. Plug that x value in. That'll give you the y, okay? Now, the y-axis intercept is right there. You put a 0 for x. It crosses the y-axis at negative 5. So there's another point. Piece of cake, huh? Come over here, factor it. Now, later when we can't factor it, we're going to learn some techniques on this, all right? But for right now, just try to factor it, all right? And what's the first thing you do when you factor? You look for greatest common factor. Okay, we're going to use the AC method. There they are. Draw me a pretty picture. All right, that's all I got. So, get that graphed up, practice those, and we'll go from there. All right, May's out.